Welcome back to another week of The Secret of a Winning Streak. So my name is Eva. I am a second-year mathematics student here at Cardiff University, and I am joined with Thomas Woolley, who is one of the lecturers here and is a reader, which is a very big, important job here at the university.
It doesn't sound, when you say I'm a reader, it just means I just look at books all day. It doesn't sound very important.
It doesn't sound very important, however, you are very important, Thomas.
Thank you, Emma.
And so today we're going to take you through another session. And last week we were looking at all these different ways to ensure that you win at lots of games, if you remember correctly. So we had the pie game, we had the toxic chocolate game, and all of our goals last week were based around how do we find strategies to try and maximize how many times we win.
Hopefully you took all of those games home and played with your friends and family and tried to trick them with the chocolate game.
Hopefully. And now this week we're going to change direction a little bit. So we're still going to be looking at different types of mathematics, but we're trying to look today at how it's used in real life and why mathematics is really important to the way we structure things. And the way we're going to do this is we're going to start today with the coin weighing game. Okay, so I am on this slide today. I have 3 different coins, and so the question is, we have a balancing scale and 3 coins, but one of those coins is heavier and we can't tell which one it is. So using the balancing scale, how do we find out which of the coins is heavier? So go ahead and use the chat and give me some answers, and how can I tell which coin is heavier using the weighing scales?
So they all look the same, all the colors are the same, they're the same size, same shape.
We've had one answer fly in already that says the one that is lower. Now, I think I understand what that person is meaning, but I wonder if anyone else can elaborate on that answer.
Interesting answer. I believe by lower, you're thinking on the screen. But the really important thing in mathematics is to try and be as clear as possible in what we mean, so that no one can say, oh, yeah, but maybe you mean this. In math, it's really important to explicitly say everything and every type of scenario we could mean. So try it again. I think you're on the right track, but try and be as clear as possible.
Oh, I like this answer. Put 2 on either side, and if it stays the same level, the one that's left must be heavier.
You're 2 steps ahead of me, whoever that person was. Well done. There's an idiom in Welsh which would be tar hoelen ar ei phen. You've hit the nail on the head there. I say it in Welsh, it's in both languages actually. Now that I've said it bilingually, I've noticed, but you've hit the nail on the head there. Well done. Okay, so on this slide, that is exactly what's happening in the first scenario. So ignore number 2 for now. Let's just look at 1. So we have 2 coins. Well, we have 3 coins, sorry, and 2 of them are on the balancing scale, but nothing's happening. So what does this mean for those 2 coins? What do those 2 coins have to be? There's a particular word I'm looking for.
Oh, and there it is. It does begin with...
there it is.
Yeah, equal.
Perfect. Well done. So in 1, the 2 coins that are on the balancing scale are equal. And exactly like the person earlier just said, that has to mean that the heaviest one is the one left over that's on the floor that we aren't currently weighing. Well done. Okay. But there's also another situation, which is in number 2, where one of the coins has tilted the scales. Can now someone tell me which coin is the heaviest here?
And remember, let's be precise, because someone has already said left. But which left? There are a couple of options for left, aren't there?
Do we talk leftist? Are we talking about left here, or are we talking this coin all the way over here? Because I know I mentioned number 2, so we can ignore number 1. But if we're looking at 2, does this one the one on the left, or is that the one on the left? Which one do we mean?
Someone else has said the one that is lowest is the heaviest. Is that precise, Eva?
Well, we're getting closer. We're getting a bit more precise. However, lowest doesn't mean you're not saying lowest on a particular thing. What lowest could mean is you could mean lowest on the screen, which would be this coin right here, the lowest on the entire screen. However, if I'm thinking correctly, you could also mean lowest on the weighing scale, which would be this coin. But you need to really be precise. Which one do you mean?
Yeah, and we've seen it now, the lowest one on the scale. So we've got there with the precision, I think.
Perfect, well done. So this is the heaviest coin here. And if I change to my next slide, there we go. So that we can see that where those two green arrows are, these are the heaviest coins in both scenarios. Well done. Okay. We're going to use this and really try and remember this method for the next question. So now we have 9 coins, but one of them is still heavier. So using the balancing scale again, how can we find out which is the heaviest coin in the least amount of weighings? So we have a timer now that's going to go on, I believe, for a minute. Yes, Hugh?
That's right. Yeah, it's a minute on this occasion. So you'll see that blue bar at the bottom of the screen move from left to right. And once it's disappeared completely, your time is up. So you've got a minute to think.
So I'm going to start that timer now. And I want you all to have a think and take your time with it if you have to, and then pop your ideas in the chat. And remember to try and be as accurate and as explicitly correct in everything you mean as possible, okay? The time is going. I think maybe next time here we'll have to add some music, like that waiting room music.
That's a good idea.
Or maybe some countdown music, maybe.
Yeah, for sure.
Are you saying I could sing if you want?
As much as we'd love to hear your lovely voice, Thomas. We need to give people time to think as well. We need concentration music.
We're getting a lot of good ideas flying in again. Well done, everyone.
Right, well done.
Yeah.
We're getting close to the end of our time now. But remember, we have 9 coins and only one of them is heavier. So in the least amount of weighings, we don't want to weigh it loads and loads of times. In the least amount
you could
possible.
do 9. You could just put one coin there and keep weighing them against it, and then keep weighing. You could do it in a lot of ways.
You could.
Yeah.
Okay.
Time is up. Yeah, and the popular answer, I'd say this time, was to do 4 and 4 and see which side goes down. There's a 2 by 2 suggestion as well, and a 1 by 1, as you suggested now as well, Thomas. But the gist of the majority of the answers suggest trying to match the number of coins on each side to see if one of the sides then drops.
The 4 by 4 would certainly beat my method of 1 by 1 by 1, but it's still not the best.
It's not the best. However, as Thomas mentioned, it is a really good method because if by pure luck you have 4 and 4 that are either equal, if those 4 are equal, that means that one coin left over is your heaviest. But that doesn't always happen because we don't know where in those 9 coins that heaviest is going to be. And so you could then have to take that down and weigh it again and weigh it again. So we want to try and find the most effective way to do this. And what I'm going to do is I'm going to simplify our question a little bit. I'm going to take the 9 coins and I'm going to make 3 piles. 3 piles of 3. So now we still have all 9 coins and one of the heaviest, the heaviest is in one of these 3 piles. And so now I'm going to follow a really similar situation to earlier, and I'm going to weigh 2 against each other, and I'm going to see what happens. And what happens in this one particularly is the left weight on the scale drops. And as individuals told me earlier, that means that left element on the scale must be heavier, this one here. Okay, so we now know that we have a pile of 3 coins. Any one of these 3 on this left-hand side could be the heaviest. So now we move on. We've done 1 weighing. And we're back to the same situation as earlier now. So we have the first situation on the left, where either the 2 coins weigh the exact same here, so they're equal, which would mean this coin is heavier. Or in the second situation, where this coin drops on the weighing scale, and so the left on the weighing scale must be heavier. And this is the exact same situation as we had earlier, yes? And which leads to this conclusion. Either in the first scenario, if the 2 coins equal on the weighing scale, the third is heaviest. But if one of the coins is heaviest on the weighing scale, the other 2 must be equal because we know we only have 1 heavy coin. What we did here was try and condense our question from 9 coins back down to our simple 3 coin situation, where we can definitively say, definitely, no matter what happens, we know which coin is going to be heaviest. And that is really important, and that's the key when we're doing big questions like this is try and think of all the different possibilities. Like Thomas said, you could do one coin and then each weigh each 8 other coins against it. But that's not very effective at a time. We don't want to have to keep weighing coins. So we try and condense it down to only 2 weighings.
So something to be said about this. So those answers we got where they said 4 and 4, what you're doing there was a binary search. You're trying to split all of your information into one pile or the other pile. And this is how computers work. They're a binary. They're either yes or no. Is this heavier? Yes. Is it heavier? No. But the weighing scales that we're using here have 3 answers. It's either left is heavier, right is heavier, or neither is heavier. So you get an extra option, and using that extra option means you can search things even faster. If you were searching through the dictionary, binary search is your friend. Is it before M? Is it after M? Is it before the letter or after the letter? So binary search is very, very powerful. So never forget that. But it's just in this case, we have a new option, which makes it even faster.
Yeah. And it's really useful, and because it can be applied to lots of different situations. Okay. We're going to move on. And we're going to move on to the next game, which is called the packing game. And personally, this is one of my favorite games because I use it every single day of my life without realizing I do. So think, what do we do on a weekly basis that means we have to pack things? Go shopping. We have to do some food shops, yes? Sometimes maybe you're with your parent or your sister or your sibling, someone at home, or maybe you do the shop yourself. And you need to go and you try and pack everything into a bag or into the car. But what happens sometimes is there's sometimes better ways of packing than others. So I know my dad, for example, my dad is like really good at packing things very effectively, so they fit really nice and tight together. Where my mum throws everything in the bag, and it means you have to get lots of different bags because she's not packing effectively. But this is really useful in lots of different scenarios and situations in life beyond shopping. And one of those is when we have to transport things on big trucks. And here we have the Mass Moving Company truck, and this truck can only carry 100 kilograms of weight. And we have all of these boxes. So what I'm going to ask you to do is, with all of these boxes, can you find a way of putting on 100 kilograms of weight to this truck? Okay, I have a timer. I'm going to start it because I have a feeling we're going to go quick into this, but have a look to see which options there are to make 100 or as close as possible you can to 100 kilograms.
And we're getting the easiest option possibly very quickly, 85 and 15, but there is a trickier one as well. So if you've seen the 85 add 15 option, can you find the trickier option as well?
But just to reiterate, we couldn't just take 20 of the 5 boxes.
No, unfortunately not. We only have 1 of each box. So please bear that in mind as well. Very good point, Thomas. Okay, we're over halfway now, so there are a few options here. So have a look to see.
Someone said 52 and 48, but I can't see a 48 box there.
You can only use what's there.
So you take some out of one box and you put it in another and make it. You can play around with the numbers there.
Okay, so the timer is now done. What type of solutions did we get, Hugh?
We got the one that we heard earlier, 85 and 15, but we have started to see the trickier one, 52, 28, 15 and 5, and there they are.
Perfect, well done. So we recognized that there are 2 different ways of getting to exactly 100 kilograms. We can't always do this, but in this situation, we actually have the exact correct amount of weight. However, what was the method we all used to find these answers? What did you do to get to these answers? That's my next question for you.
We've got addition, which is correct, I suppose, in a way.
Addition, yes, we did. We did add all these values up to get to 100. Yes, that is good. Seen someone else say maths? Yes. All maths, all different types of maths. But there's a particular type of method we used, which meant trying something and seeing if it worked and looking at all these different values. Can anyone tell me what the title of that is? It's possible we don't know, and if you don't, that's great. You'll learn something today.
I haven't seen it yet, ever. So you might have to explain.
I think I have just seen it actually in the last couple of
Oh, there it
seconds.
is. Yeah, yeah. I've
Someone
seen it now as well.
someone did say it. Well done, them. Trial and error. That is exactly what we use today. Because what we did was you tried some different values. You thought, okay, does 85 add with 5? Yes, it makes 90. However, we're still 10 away. So 10 bigger than 5 is a 15. Oh, we have a 15. Great. And that's what we did is you tried something, see how close you are to your end goal, and try it again. And this is a really, really important method in mathematics. We use it all the time, and sometimes it is the best method to find different answers. And currently, correct me if I'm wrong, Thomas, trial and error is the most correct method for these type of questions.
So there are other techniques you can use. So you could do a smallest first, smallest to biggest. You order your packages, put the 5 in first, and then the 15, then the 28, and that would get you a pretty good answer. But then you'd put the 42 in, and it wouldn't quite work. You could start largest first. Just put the 85 in, and then put this. You couldn't put the 65, and so you then put the next largest in. Again, wouldn't quite get us there. But trial and error in this case is the only way to know you have an exact solution. And that's the key thing. If you can do, as a mathematician out there, all you beautiful, wonderful mathematicians, if you can find a better way that works consistently across any number of packages, you can win $1 million. But that means nothing. In the world of business, this is worth billions and billions. So you would be famous forever if you can crack this problem.
Yeah, it's a very famous problem. I'm going to give you another one now that's going to be slightly harder. And we need to try and find, can we make 150 from these packing cubes? And it's possible you can't. So if you can't, try and get to the value as close as possible, okay? I'm going to start the timer once more. So that blue bar at the bottom of the screen is moving. It's moving. So have a think to see, can you get to 150 or as close as possible to 150 as well? Because that is also very important. Maybe we can't make the full answer, but it's still useful to know how close we can get to it. So have a go.
And remember, this isn't Kahoot. It's not who can get there quickest. You've got 2 minutes to answer or try and get as close as possible. I'm seeing a lot of 95 and 65, but I think those people might need to double check their maths.
A little bit. So 95. So I'm thinking what people are thinking are, I see a 9 and a 6, and that makes 15. You are correct. However, those 5s do add up to another 10, which is going to bump your answer up to a 160. And if we put 160 kilograms on this van, I think it would break, unfortunately. So we would still like it to move. So when I say closest to 150, try and get it either 150 or below, as close as possible below, because we still want this truck to be able to move places.
And one thing I would say is that if you are struggling and you really can't do mental arithmetic, do not worry. I'm terrible at mental arithmetic, and I'm a reader, whatever that means. So mental arithmetic is a great skill, a wonderful skill, but it's not the be all and end all of mathematics. We carry calculators around with us nowadays, so it's a great skill if you have it, but don't worry, maths is much wider than just being able to count.
I completely agree. When I was in school, I did not particularly enjoy doing my times tables and having to add things. And I can't do lots of these sums really quickly anymore. But after many, many years of studying mathematics, you come to realize maths is a lot more than just numbers. And it is really, really cool. So
That's why,
don't
I like
worry.
to compare it to English. Shakespeare is much more than the alphabet. Knowing the alphabet is one thing, knowing Shakespeare is completely different.
Yeah. So we've just come to the end of our time there. Okay, so has anyone figured it out? Has anyone found out if we can make 150 or as close as possible to 150 and still have the van moving? Let's have a look. I can see 147. So with the 95 and 52, that is really close. Well done. Okay. So that'd be really useful. Say we can't get to 150, at least we can transport 147 kilograms with, which is very, very close. Has anyone been able to find if we can make it 150 exactly? Or can anyone say we definitely can't? Because that's also really useful. Someone saying there is none. And can you explain why, maybe? Okay. I think I'm going to move on to the next slide and tell you we actually can make 150. And we make that with the 65, 42, 27, and 16, which is very hard. We
So yeah,
weren't
if you didn't get the answer, do not. This is a very, very hard problem. As I say, it's worth $1 million. It's hard.
It is a hard question. And the reason why is because we keep going through this trial and error method. You keep trying different numbers and seeing does it make as close as possible to 150. But this can take a long, long time. If we have more and more boxes, more and more values, the amount of combinations that's possible becomes really, really, really big. And it's a lot of time to sit and have to do sums over and over again. So as Thomas said, don't worry if you didn't get it, but it's the way that the method we took to find that trial and error. So if you do, as Thomas say, find a better method than trial and error, please let us know, because as he mentioned, you could be in the chance of getting $1 million, which would be really useful. I think now here we're going to move on to the Kahoot, if that's okay.
There we are. And there was one person, I think they probably just mistyped their numbers, because I think they had the right numbers, but might have forgotten one digit. So to that person, well done. I think
Well
you probably
done.
did get it correct. Thank you very much, Eva and Thomas. And I'm already looking forward to the third session next week. But thank you very much for joining us. I'll see you next week at the same time and same place. Diolch yn fawr iawn I bawb hefyd am ymuno efo ni. Wnawn ni weld chi wythnos nesaf. See you next week.
Thank
Hwyl am
you,
y tro.
everyone. Diolch.
Diolch. Ta-ra.